Hey folks, welcome back. In this video we're going to go over question 3 from the 2019 SQA Advanced Higher Physics exam paper. So let's get started. Question 3 says a gymnast in a straight position rotates around a high bar. This is shown in figure 3a. So there's the high bar and the gymnast of a length 2.1 meters. And it says the mass of the gymnast is 63 kilograms. With arms extended, the total length of the gymnast is 2.1 meters, and the gymnast is rotating with an angular velocity of 7.9 radians per second. Part A says with arms extended, the gymnast can be approximated as a uniform rod. Using this approximation, show that the moment of inertia of the gymnast around the bar is 93 kg/meters squared, and there's 2 marks available here. Well, looking back at the diagram, if we're thinking about the gymnast as being a uniform rod, then we can think about the rod moving about its end rather than around its centre, since it's the gymnast's hands, the end of the gymnast, that's rotating about the bar. So we can say treat the gymnast like a rod rotating about its end. So here we're trying to find the moment of inertia of the rod. We know the mass of the gymnast or rod is 63 kilograms, and the length L is 2.1 meters. So writing down the equation for the moment of inertia of a rod rotating about its end from the relationship sheet, we have I rod equals a third ml squared. Substituting in the numbers gives a third times 63 times 2.1 squared, and putting that into your calculator should give you an answer of 93 kg/meters squared. Part B says the gymnast now makes a pike position by bending at the waist. This is shown in figure 3b. So there's the pike position there. And it says this change of position causes the moment of inertia of the gymnast to decrease to 62 kg/meters squared. B part 1 says explain why making a pike position results in a decrease in the moment of inertia of the gymnast. And there's 1 mark available for this. Well, we could say that more of the gymnast's mass is now closer to the axis of rotation, i.e. R has decreased, so I also decreases. And remember, that's because moment of inertia I and the distance from the axis of rotation R are directly proportional. So if one decreases, the other decreases. And lastly, B part 2 says by considering the conservation of angular momentum, determine the angular velocity of the gymnast in the pike position. And there's 3 marks available here. Well, to answer this, let 1 represent before the change in position and let 2 represent after the change in position. And using the principle of conservation of angular momentum, we can say that the total angular momentum before the interaction or change here is equal to the total angular momentum after the interaction or change. So because there's only one object here, i.e. the gymnast, we can say that I1 omega 1 is equal to I2 omega 2. And it's this omega 2 variable that we want to find. So substituting in our numbers, we have 93 for the moment of inertia before the change in position, times 7.9, which is the initial angular velocity of the gymnast, which we're told at the start of the question, and that's equal to 62, which is the final moment of inertia after the change in position, times omega 2, which is the final angular velocity of the gymnast after the change in position. So dividing both sides by 62 here to get omega 2 on its own, and putting that into your calculator should give you an answer of omega 2 equals 12 radians per second. That's all for this video folks, thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.